Okay, so building on the example that we saw about if I am actually 80% successful at making a free throw, we'll kind of get some of those pieces that we had discussed on that and formalize them a little bit more here. So on page 2, the important ideas. The first thing would be the hypotheses. So we begin by making an assumption, assuming that I was actually 80% successful, until we had evidence to convince us otherwise. So that original assumption, we call that the null hypothesis. Symbol would be H sub 0, that means the null hypothesis. And for now, we're going to be looking at one of two things. We are either testing the true proportion, which we were on that last example, or the true population average. Okay, so those are the two parameters that we will be assuming in the null hypothesis. Now, the alternative hypothesis generally is what we have some preliminary evidence that's giving us some, some reason to believe that maybe the null might not be true. So the alternative hypothesis, we mark that as H sub A, so alternative. And the alternative is either going to be about the parameter the mean, or the parameter proportion. So for the example before, my percent was less than what I claimed to be in terms of my success. So the alternative hypothesis for that previous problem might be that the true proportion is actually less than 80%. We could look at not equal to, the true proportion or true mean is not equal to what we assume in the null, or the true proportion or mean is greater than what we assumed to be in the null. So our alternative is going to be one of these three. Think inequality for that. Either not equal to what we assume in the null, less than what we assumed, or greater than what we assumed. Now, once we have our hypotheses, we set out to test the hypothesis to see how unlikely the outcome that we obtained truly is given the null hypothesis. When we find that probability, the percent of how unlikely that is, that's what we call the p-value. So in words to identify, to explain what the p-value means, we assume the null hypothesis. We want to state that in context. Assuming the null hypothesis is true, there is whatever the p-value is, that percent probability of getting a sample percent or a sample mean to be lower or higher, depending on the case, purely by chance. Okay, so if I would copy that down so you have like the basic wording of what a p-value is. In the previous problem, I would say, assuming that Mrs. Manuel is 80% successful, there is about a 1% probability of getting or making 64% or fewer free throws purely by chance. Now, once we establish what that p-value is, what it means, the conclusion we generally base off of the 5%. 5% or less is considered highly unusual to have occurred purely by chance. So if we do have a p-value to be less than or equal to 5%, we will reject the null hypothesis, meaning we have convincing evidence for the alternative. If the p-value isn't less than, actually I do not want the equals here. I want it purely less than. If the p-value is greater than or equal to 5%, it hasn't met that requirement to be unusual enough. So we will not reject the null hypothesis. We, in other words, fail to reject the null hypothesis. We won't have convincing evidence then for the alternative. Now, in the previous scenario, our p-value was estimated to be about 1% through our simulation activity, so it would fall into this category. And I would say then, well, since the p-value is since 1% is less than 5%, I will reject the null hypothesis that Mrs. Manuel is 80% successful, and I have convincing evidence that Mrs. Manuel in general, she will make less than 80% of her free throws. That's kind of the idea. So let's see this in an example. The Phillie Fanatics. Nationally, the proportion of red cars on the road is about 12%, 0.12. A statistically minded fan of the Philadelphia Phillies, whose team color happens to be red, wonders if Phillies fans are more likely to drive red cars, if there's more than 12%. One day during a home game, he takes a random sample of 210 cars parked at Citizens Bank Park, the Phillies' home field, and counts 35 red cars. Item A, let's state appropriate hypotheses for performing a significance test. Be sure to define the parameter of interest. So the hypotheses, well, first, we're looking at the true proportion of red cars driven by Phillies fans. So P will represent the true proportion of Phillies fans with red cars. That's our parameter, true proportion of Phillies fans with red cars. The null hypothesis is we begin by assuming that it is the same as the national percentage, which was 12%. So I use my symbol H sub 0. The null hypothesis P equals 0.12. Now our statistically minded Phillies fan thinks that maybe the percent is actually higher. So the alternative hypothesis is that P is greater than 0.12. Do we have some evidence suggesting that that might be the case? So preliminary evidence is our p-hat value. Well, in their random sample of 210 cars, 35 of them were red. So 35 out of 210 Phillies fans, which as a percentage is about 0.17, that is higher than 0.12. Could that have occurred purely by chance? Now, we'll talk later about how you calculate the p-value. For now, it's been done for us. And they tell us that the p-value for this test is 0.0187. So let's start by interpreting what that means. Okay, the probability, or the p-value, is the probability of obtaining a sample result or more extreme purely by chance if the null hypothesis is actually true. So in context here, assuming the proportion of Phillies fans with red cars is actually 0.12, there is a 0.0187 chance of getting a sample proportion of what we observed, so 35 out of 210, or more purely by chance. Interpreting the p-value is a huge piece for statistics to understand what the results are telling us and then what conclusion we can make from there. So I would read this again, maybe pause the video, read this again, and really try to understand, what does this tell me? It tells me that if we assume that the Phillies fans drive, 12% of them drive red cars just like the national percentage, if we assume that to be the case, then the probability of us getting 17% of Phillies fans to drive a red car purely by chance, that's only going to happen a little over 1% of the time. That's really unlikely. What conclusion will we make? Well, the conclusion is comparing our p-value to our 5% cutoff. Because the p-value, 0.0187, is less than 0.05, we can reject the null hypothesis and conclude that we have convincing evidence for the alternative, that more than 12% of Phillies fans have red cars. When we conclude about the alternative, we are not concluding with that exact sample percent that we obtain. We don't know what the exact percentage is. It could be 17%, it could be 16%, it could be 15%, it could be 20%. We don't know. The sample is giving us evidence that it is more than 12%, not just because 17% is greater, but because the probability of getting 17% or more purely by chance, if the truth was actually 12%, is so unlikely. The p-value is what's telling us how unusual this result is. And because it is so unusual to have occurred purely by chance, we do have evidence that the truth is actually more than 12% of Phillies fans drive red cars.